Good afternoon, students. In continuation with nyquist plot, today we will solve some more problems on nyquist plot. First, we discuss behavior of right half rule. Suppose GSHS is given as 1 by S minus 1, fold in the right half of S plane. Means if we put S is equal to J omega, we get Gj omega Hj omega is equal to 1 by minus C plus J omega. When omega approaches to infinite, this is the point minus C J minus C plus J omega. So when omega reaches infinite, it means when omega reaches infinite, then in that case angle is 90 plus 90. So this factor S minus 3 will contribute plus 90 degree in the denominator. As omega approaches infinite, angle of Gj omega Hj omega is minus 90 degree. Plus 90 degree in denominator. So when omega reaches or approaches to infinite, angle is minus 90 degree. And when omega is plus 0, omega is plus 0 means this is the point, and in this case angle is 0. So we can say that when omega approaches plus infinity, S minus A, this factor contributes plus 90 degree, and when omega is plus 0 or minus 0, in both cases we get minus C plus minus J0. It means in both cases we get if sorry when omega is 0, this there is an angle of 100. Contribution of angle is plus 180 degree in the denominator. So when omega is plus 0 or omega is minus 0, we get this point, and angle contribution is plus 180. So this factor S minus A contributes plus 100 and plus 90 degree when omega tends to infinity, and when omega tends to plus 0 or minus 0, angle is contributed plus 180 degree in the denominator. Then sketch the nyquist plot for a system with GSHS is equal to 10 S plus 3 divided by S minus 1, and comment on the closed loop stability. First, S is equal to 1, it means that there is one pole in the right half S plane. So n is equal to minus p or n is equal to minus s, it means that this in this case nyquist plot must encircle minus 1 plus j point once in a clockwise direction for stability of system. Then put S is equal to j omega, we get this equation, and when S approaches to j infinity or omega approaches to plus infinity, angle contribution by this term 3 is 0. Angle contribution by 10 is 0. Angle contribution by 3 plus j omega is 90. Similarly, angle contribution by in the denominator by j omega is 90 and by this angle is 90 degree. So this 90 and this 90 is cancelled out and we get 0. Magnitude is 0 and angle is minus 90 degree. And when omega tends to 0, it means that here omega is 0, it means this 10 contributes 0 angle, this 3 contributes 0 angle, this j omega contributes 90 degree and s minus a. This factor contributes plus 180 degree when omega tends to plus 0. So we get infinite magnitude in this case and angle contribution is minus 270. So we total, this is the final angle, final angle minus initial angle is given by minus 100. So there is angle contribution is 180 degree in clockwise rotation. Well, in next case, in section 2, joining s is equal to plus j omega or when omega tends to plus infinity and when omega tends to minus, when omega tends to plus 0 and omega tends to minus 0. So starting point is when omega tends to plus 0. Omega tends to plus 0, we get in magnitude is infinite and angle is minus 270 degrees. Similarly, for terminating point, when omega tends to minus 0, omega tends to 0, minus 0, this term is 0, this term is 0, but so angle contribution is 0, angle contribution is 0. In this case, when omega tends to minus infinity, angle contribution is minus 90 degree, while in this case, angle contribution is plus 90 because it is in first quadrant. And in case of when omega tends to minus in 0, it is in third fourth coordinate. So it angle contribution um, by this term is minus 90 degree and angle contribution by this term is 180 degree plus 180 degree. So we get infinite magnitude and angle contribution is minus 90 degree, final value minus initial value, we get plus 180 degree anti-clockwise rotation. Then rationalize gj omega and hj omega and separating the real part and imaginary part and equate imaginary part is equal to 0. We get the phase crossover frequency because on when imaginary part is 0, we get the value of phase crossover frequency and value of phase crossover frequency is under root 3. Then substituting the value of phase crossover frequency in real part, we get the value of intersection of nyquist plot on the real x. Nyquist plot is like this. In first case, magnitude is 0, angle is minus 90, terminating point is magnitude is infinite, angle is minus 270. So, first angle is minus 90 and magnitude is 0. Then this is the polar plot for open loop transfer function. Magnitude is infinite and angle is minus 270. Then take the mirror image of this polar plot this and joining of omega is equal to plus 0 to omega is equal to minus 0 is there is 180-degree anti-clockwise rotation. So 180-degree anti-clockwise rotation. These 2 points are joined by Nyquist plot and radius of Nyquist plot is infinite. Yeah. And this intersection point is, we get this intersection point by rationalizing gj omega hj omega and then equating imaginary part is equal to 0 and substituting this value in real part, we get the intersection point is minus 10. Means this point is minus 10. It means that this Nyquist plot encircle minus 1 plus j0. How many times? This is clockwise, so minus 1, clockwise minus 1, anti-clockwise plus 1. It means that n is equal to minus 2 plus 1 it is equal to minus 1. And according to the equation, according to the open loop transfer function, P is equal to 1. It means n is equal to minus 1 for stability. So this system is stable system. Next question is sketch the Nyquist plot for a system with open loop transfer function given by GS HS is given by this. In this open loop transfer function, there is one pole in the right half plane. So P is equal to 1 and Nyquist criteria for stability is n is equal to minus P or n is equal to minus 1. J omega and Fj omega is given by this expression. Similarly, wait for value of Gj omega and Hj omega is given by this expression. Magnitude is given by this and angle is given by, first we calculate the magnitude. When omega is 0, when omega is 0, when omega is infinite, we get the value of magnitude which is 0.05 k. So in this case, we substitute 0.05k and magnitude. This term contributes 90 degree, this term contributes 90 degree, 90 degree and 90 degree. So we get 0.05k and angle is 0 degree. And when omega tends to 0, when omega tends to 0, omega is 0, omega is 0, omega is 0, and in this case omega is 0, magnitude is k, and angle is omega is 0 means 0 angle contribution, 0 angle contribution, 0 angle contribution, but this s minus a gives 180 degree, so we get k and angle contribution is minus 180 degree. So angle of rotation is clockwise rotation, 180 degree clockwise rotation. Starting point is 0.05 k and angle is 0. Starting point is this 0.05 k and angle is 0, and terminating point is k and angle is 180 degree and clockwise rotation. Clockwise rotation means this is the clockwise rotation. So this is the polar plot of given open loop transfer function, and this is the mirror image of the polar plot. Then we rationalize this equation for open loop transfer function, and then imaginary part is equal to 0. Calculate the phase crossover frequency and substitute this phase crossover frequency in real parts. We get the intersection point of this nyquist plot with real negative axis, which is minus 1667. So this is the point minus 0.1667 multiplied by k. For the stability, n is equal to minus 1 because there is one pole in the right hand side. P is 1, it means n is equal to minus p, n is equal to minus 1, and in this case, this minus 1 is encircled by, this is anti-clockwise direction, so n is equal to minus 1. So this system is a stable system, and in this case, O, Q, O, Q, O, this is origin O, absolute value of OQ is greater than 1 because value of Q is to the left hand side of minus 1. So magnitude of or absolute value of OQ is greater than 1, and value of OQ is 0.1667 multiplied by K, and this is greater than 1. So value of K is greater than 6, or we can say that value of k is in between infinity and 6. In this range, system is stable. Access the stability of system with GSHS is equal to 101 plus 5s divided by s raised to the power 4 1 plus s. use nyquist criteria. In this case, there is no pole in the right hand side. It means P is 0, P is 0. It means N is also 0, or according to the nyquist criteria, if for stability of system there is no encirclement of point -1 plus j 0. When S is equal to plus infinity to, first we calculate the starting point when omega tends to plus infinity, when omega tends to plus infinity. This term contributes 90 degree, this term contributes 90 degree, and this term contributes 90 plus 90 plus 90 plus 90, 360. 360. So we get starting point and terminating point when omega tends to plus 0. When omega tends to 0, this term is 0, this term is 0, means angle contribution by 1 is 0, angle contribution by 1 is 0, and angle contribution by s raised to the power 4 is equal to 360. So we get 360, and there is no rotation of the plot. In this case, there is no rotation of the plot because we get 0 degree. But according to the question, magnitude of inverse 5 omega by 1 is greater than 10 inverse magnitude of 10 inverse omega by 1. So we can say that QR is minus 360 plus 10 inverse 5 omega by 1 minus 10 inverse omega by 1. This is positive quantity, small positive quantity. So we can say that this psi r is greater than minus 360 degree, or psi r is greater than minus 359 or 356 or 350 degree, etc. So we can say that this section is in the first quadrant. When omega tends to infinity, magnitude is 0 and angle is minus 360, and when omega tends to 0, magnitude is infinite. And in this case, when omega tends to plus 0, when omega tends to minus 0, when omega tends to 0, we get same angle as in previous case, and when omega tends to minus infinity, magnitude is infinity and angle is plus 360. So angle of rotation is 720 anti-clockwise rotation. So when omega is infinity, magnitude is 0, and this nyquist plot, this is the starting point and this is the ending point, and rotation is 720, this is 360, and second rotation gets 720 anti-clockwise rotation, and last is and this. So minus 1 plus j is encircled by anti-clockwise rotation. Anti-clockwise rotation means n is equal to plus 2. So we get unstable system. Use nyquist analysis to determine the stability of range of K. If GSHS is given by Ks plus 5 divided by SS minus 2. There is one there is one pole in the right half, means P is equal to 1, N is equal to minus 1. For stability, means nyquist plot must encircle minus 1 plus J 0.1 in clockwise direction. So this is G J omega H J omega, which is equal to K 5 plus J omega divided by J omega minus 2. When S is approaches to plus infinity or starting point, for a starting point, this term gives 90 degree, this term gives 90 degree, and this term also gives 90 degree. So we get a starting point as 0 and angle is minus 90 degree. Similarly, when omega tends to plus 0, this term contributes to 0 because omega is 0. So omega is 0. This term contributes 90 degree, and this term, because it is in form of S minus A. So when omega tends to plus 0, this term contributes plus 180. So we get magnitude is infinite in this case and angle is 270, minus 270. In first case, magnitude is 0, angle is 90, and terminating point is infinity and minus 270. So this is the polar plot for the given open loop transfer function. This is the mirror image of polar plot, and omega is plus 0 and omega is minus 0 is joined by 180 degree. When omega is plus 0, magnitude and angle is given by infinite and minus 270 degree. When omega tends to minus 0, this term gives 0 degree, but when omega tends to minus 0, it means that it is in negative side of imaginary axis. So this term contributes minus 90, this term contributes same 180 degree. So we get infinite magnitude and angle is minus 90 degree in this case. So total angle of rotation is plus 180 or 180 degree anti-clockwise rotation. 180 degree anti-clockwise rotation. So minus 1 plus J0 is encircled by clockwise, first clockwise, second clockwise, means minus 1, minus 2, and this is anti-clockwise plus 1. It means n is equal to minus 1. Then for finding out the range for this system is stable, first you rationalize Gj omega and H omega and separate the negative and imaginary part. Then equate imaginary part is equal to 0. Calculate the phase crossover frequency, and when you substitute this phase crossover frequency in real part, you get the intersection point of nyquist plot with the negative real axis. This is the true point which is given by minus 0.5 k. So magnitude of OQ is greater than magnitude of minus 1. So we can write that 0.5 k is greater than 1 or k is greater than 2. For this range of gain, system is stable. Okay, time is over. Thank you. Um, Aditi, hello, Aditi, Aditi, Aditi.